Hey, welcome. Every time you flip a light switch or charge your phone, you're plugging into the single largest machine on Earth, the power grid. But here's the thing. That machine is over a century old, and it is seriously due for a massive upgrade. So today, we're diving into the smart grid, the intelligent nervous system that's going to power our future.
So to really get why we need this change, you just have to look at how we make our power. And this chart, wow, it tells a dramatic story. Back in the year 2000, the US got over 200 times more electricity from oil than it did from solar. Now, fast forward to 2018, and it completely flipped on its head. We generated almost 3 times as much from solar as we did from oil. I mean, that's not just a small shift. That is a complete revolution in our energy landscape.
And that, of course, raises a huge question. The grid we have today, well, it was designed for a world of big, centralized power plants. It just wasn't built for a world where energy comes from millions of different rooftops and sprawling wind farms. So, is it ready for this new reality? The short answer? No, not even close.
So what's the solution? Well, it's something called the smart grid. You've probably heard the term thrown around, but it's so much more than just a buzzword. It's a total reinvention of our entire electrical system. So let's break down what that really means. Understanding the smart grid is kind of like that old story of the blind men and the elephant. It's not one single thing, it's really a whole collection of interconnected technologies working together. It's the smart meter in your home telling you when electricity is cheapest, it's automation that can fix problems before they even cause a blackout, and it's the software that seamlessly blends all that wind and solar power right into the system. But if we had to boil it all down to one core idea, this would be it. The smart grid is an intelligent system that connects suppliers and consumers through a two-way network. And that phrase right there, two-way network, that's the game changer. That's what makes everything else possible. And this comparison makes that huge shift crystal clear. The old grid, it's a one-way street. A power plant makes electricity and it flows down the line to you. That's it. End of story. But the smart grid, it's a two-way conversation. Energy and just as importantly, information flow back and forth. Your solar panels can tell the grid they have extra power to share, and your electric car can ask for a charge when demand is low and electricity is cheap. Okay, but for that two-way conversation to actually work, everything on the grid, from your toaster to a massive power plant, needs to speak the exact same language. So how in the world do you make that happen?
And this is a massive challenge when you stop and think about it, right? Your home's smart thermostat, your neighbor's EV charger, the solar panels down the street, the local substation. They're all made by totally different companies. How do you possibly get them all to coordinate with each other perfectly?
Well, the answer is this crucial concept called interoperability. The easiest way to think of it is like the grammar of the grid. It's the set of rules that lets a device made in, say, Germany, communicate perfectly with a device made in California, making sure they work together as one big team. So who writes these rules? Well, one of the key architects is IEEE, the world's largest technical professional organization. These are the global experts who literally write the technical rulebook for our modern world. And we're talking about a massive rulebook, over 1,100 active standards just from them alone. And they don't do this in a vacuum. IEEE works super closely with government bodies, like the U.S. National Institute of Standards and Technology, or NIST, to create a single, unified framework. This is the official playbook that ensures every single part of the smart grid can speak the same language. Okay, so we have a common language, but what does that actually let us do? Let's look at a couple of real-world examples that show you the incredible power of these standards, from what's parked in your garage all the way to the local hospital. So let's start with a scenario that's becoming more and more real every day. Just picture it. Thousands of electric vehicle owners in your city all get home from work and plug in their cars at pretty much the same time, right around 6 p.m. So here's the problem. A single common EV charger can pull up to 19.2 kVA of power. Now, to put that in perspective, that's almost as much electricity as your entire house uses. Now imagine thousands of those switching on at the exact same moment. Without standards to coordinate that surge, you'd have chaos. So that's how standards can prevent a problem from happening in the first place. But what about when disaster strikes? Let's switch gears to another scenario, a citywide blackout. This is where standards enable a really remarkable technology called a microgrid. So here's how it works. Step 1. When the main grid goes down, a local area, like a hospital campus, can perform what's called an emergency separation, safely disconnecting itself. Step 2. It then uses its own local resources, like solar panels and batteries, to provide uninterrupted power to its critical systems.
Then, step 3, once the main grid is stable again, it automatically and safely reconnects.
And the truly incredible thing about all this life-saving coordination, this little island of power and a sea of darkness, is that it is only possible because every single component is speaking the same language, following that exact same set of standards.
So we've seen how the smart grid works in a crisis. But what does this smarter, more connected system really mean for our everyday lives? Why should you care?
This chart, which is famously known as the duck curve, perfectly shows one of the biggest challenges with renewable energy. See that deep dip in the middle of the day? That's when millions of solar panels are pumping out cheap, clean power, so we don't need as much from traditional power plants. But then, as the sun goes down and everyone comes home, turns on their lights, their TVs, demand just skyrockets. The smart grid is the brain that lets us manage that wild swing smoothly and efficiently.
So when you put it all together, what's the payoff for us? Well, because the grid is smarter, it's way more reliable. It can actually reroute power around a fallen tree to prevent a blackout. By being more efficient, it cuts down on the roughly 5% of energy that's currently just wasted moving it around, which of course saves everyone money. It's greener because it's specifically designed to handle the unpredictable nature of wind and solar. And finally, it's more secure, with modern defenses built right in to guard against cyber threats.
And that's why this isn't just some small incremental upgrade, it is a fundamental transformation. As the publication Smart Grid Today puts it, this is, and I quote, one of the largest opportunities of this century. Look, this isn't science fiction anymore. The standards are being written, the technology is being rolled out, and the grid is getting smarter every single day. So the final question really isn't about the technology, it's about us. Are we ready to plug in?